Good morning, everybody. Hopefully you guys are doing well today. If you can give me a green check in chat and make sure you can hear me and see me. And while you're doing that, I promised you guys that I would have some time today to go over any questions you might have had about sort of anything that we've gone over thus far. I've kind of been pushing it back because I wanted to just get through all of the material. So if you had a question about something, be really specific about what sheet it's on, because I'm going to have to search for it. So like practice 3, 4, 5, or 6, even the kind of unit review, I could give you some pointers on that, unit 2 review. And yeah, learning guide for sure. Throw in the question number, go with like the sheet first, so like learning guide, question 2, and then things like that. And I'll be able to go through anything you had there. Looks like I've been getting a lot of green check marks, so everyone seems to be picking up what's going on. There's still a few of you who haven't given me a green check, which is a little bit unusual. Normally you guys all have by this point, so if you're maybe just forgot, you want to throw that in, I'll be able to make sure everyone's kind of with me before we get started here. That's looking much better. Excellent. I see lots of people typing. We are going to start Unit 1, Jade, but if we have, I want to make sure I go through any questions you guys might have first. So if there's questions and we don't get through all of the lesson 1, then so be it. I don't want you guys to leave here today with a bunch of kind of uncertainty and then having you guys write this test between now and next Tuesday. So we got a couple questions coming in. We have, for whatever reason, this isn't scrolling all the way, so I'm going to have to lose that for now. Learning guide, lesson 6, worksheet, question number 3. I'll get to that for sure. Learning guide, volume of right prisms, cones, pyramids, question C. Alex, if you had a number to go along with that, that would be awesome, unless it's just labeled as that, but I think there's probably maybe a number to it. One thing, while you guys are writing in questions there, that I wanted to go through that I hadn't had a chance to yet is, there was this question, I don't know if you remember, it was probably like 3 classes ago. I went all the way through it and I got to the end and I had the answer wrong, and then I didn't have any time to figure out where I went wrong, but I went back to my desk and wrote it all down, and I made a really silly error, and I just wanted to kind of correct my error just in case you guys cared. I cared more than you probably, but anyways, it was this question. I think it was 2. Yes, this is 2D off the lesson 3. I put it in right here. This is where my little error was, and I want to just explain what the error was and then how to make it right. So when I was calculating the area of the bottom, the area of the triangle on the bottom, this equilateral triangle here, I wanted to make sure I got it right. What I did was I took the area, or the distance from the center to the edge here to be 5. But if you look at this picture, even from here to here is 5. So this is a lot shorter of a distance. So then I thought, how do I get that if it's not half? So what we did in the question is we actually found the complete height of this bottom triangle, and we found it's way over here on my right-hand side. We found it to be 8.66. So the distance from the center to the edge would be half of that. So instead of that being 5, this should be 4.33. Now I know you guys probably don't really remember doing that and don't remember me getting it wrong, but I wanted to make sure I got that right. So this is the 4.33, which changes this calculation here. Now I'm not going to sit and go through it all, but just so you guys know, that should be 4.33. and then you can find the slant height from there, and then that'll change the answer. So I just wanted to correct that. Looks like the first question we have is lesson 6, worksheet number 3. 1, 2, 3. This one. This is a really a good question actually to go over. And I think once I explain the trick to it, you guys will be like, oh, that makes sense. But you're probably thinking, Mr. Borden, we never went through this this top piece, which is, a weird shape. So how are we possibly going to find the surface area of that? We're coating the outside of the tank, so it's dealing with surface area. I want to just mention one thing, and as soon as I mention it, it might kind of click in your brain. If we took some scissors and we cut down this line right here, and then I cut along the top, and then I cut up here, and then I cut along the top here, if you can imagine I cut that shape out, what would it make? What shape would it make if I cut it out and folded it flat onto my table? A couple of you typing. It would be half cylinder. This is true. If you think about this red line I've drawn, if I just put it flat, I end up with a rectangle. Yeah, Haley, you were on it. You guys got the half cylinder thing. All it is a rectangle where I know that this is going to be 16 meters because this is the same here. And then this is just going to be the circumference, or I should say half the circumference of the circle here. So I do have half a cylinder, so I could use the cylinder formula, and essentially that's all it is. So if you got to a point on your test or a quiz and you're like, oh my goodness, I can't find the shape and maybe it looks like a cylinder but it's half and it's all confusing. If you just think about what it is, it's just a rectangle. And then if we have this circle on the top here, we have half a circle, but we have half a circle on the bottom as well. So all we have there is just a circle. So we have the surface area of a circle plus the surface area of a rectangle. So when we look at these formulas, sometimes the formula sheet kind of gets a bit overwhelming because there's so much on it. And it's like this and that and the other. If you just take a second and think about the shapes that you're dealing with, there's nothing wrong with just simply finding the surface area of each individual shape and then just adding them all together. You don't have to use the formulas and put it all together. So there's nothing on any test or anything like that where it says, you must do it this way. If you're finding the surface area, whatever way you want it, whatever way makes sense in your brain, just go with that. So don't be afraid to just find the surface area, each of the shapes that makes it up, like basic rectangles and circles, and then just add them together. But some of you had mentioned it's a half a cylinder, so we'll stick with that. Couldn't you also do the surface area of a cylinder divided by 2? Yeah, Abby, that's what I'm going to do. And if you look at the surface area of a cylinder, if we think about the cylinder, surface area of cylinder is 2 pi r squared plus 2 pi r h. And this 2 pi r h is just the rectangle, and this is our circle. Now, if we think about dividing it in half, because of course, if I had a full cylinder, it would go like this, and I'd have the whole thing all the way down to the bottom. But I don't, so I just have half. So if I divide each of these by 2, or if I divide everything by 2, maybe I'll divide each by 2 separately. That might be a little bit more sense. The 2's cancel, the 2's cancel, and if I have the one red, one blue, surface area of half a cylinder is equal to pi r squared plus pi r h. The 2's just cancel away. You'll notice pi r squared is the area of a circle, and pi r h is that rectangle I drew earlier. But the pi and the r is just the circumference formula, and then the h is the other half of that. The other thing I have here is a rectangular prism, kind of a box, if you will. So I'm going to probably do the sides of my rectangular prism. I have this bottom, we'll call it C. I'll do the sides of the rectangular prism separately, so just to make sure I don't skip out anything. So let's do the cylinder first. Pi, the radius is 7 squared plus pi, 7 times. Getting the length of the cylinder is important. We're going to put 16 in for the height instead of 25. So make sure we don't make a mistake on that. All right, find my calculator here. So pi times 49, 7 squared, it's 153.938. And then pi times 7 times 16 is 351.858. So I'm going to add those things together, making sure to keep a couple decimal places. 505.796. So that is my half a cylinder. So that's the first part. The second part would be to find the area of my rectangles here. So to make up my rectangular prism, it doesn't matter which one we do first. The only trick here is that this rectangle in here is shared between the half a cylinder and the top of that rectangular prism, so we don't include that in our surface area. So maybe I'll do this front face, I'll call this A, and that back face is A. So this is going to be the surface area of my prism. How many A's do I have? Looks like I have 2 of those, so I have 2 times, I'll write A up on the top here. 2 times length times width. So the length of that is 25 and the width would be 16. To that I'm going to add, think about those are my A's. Let's go with the top and the bottom. I'll call this the bottom B, and then the top, kind of tricky where I'm putting my letters. So this is B now. And B is going to be, I know that this is 16. What about this part here? What's this distance? So I have 2 of those, 16 times, Savannah, I'll get to that in a second. I have the distance across here. If this is 7, then this together would be 14. So I got the front and the back, top and the bottom, then I have this side C, maybe we'll call it C, make it green, and I only have 1 of those. So C is going to be 16 by 14. So I'm going to do all that math, add it all up. 2 times 25 times 16 plus 2 times 16 times 14 plus 16 times 14. 25 by 16, 14 by 25. Should be a 25 here. Makes more sense. Start that again. 2 times 25 times 16 plus 2 times 25 times 14 plus 16 by 14. Once 1724. Now I have to add these two together. So my surface area total is going to be the 505.796 plus the 1724. So 2,229.8 meters squared, not cubed. Surface area squared. Abby, you got 14 there. Good. That's kind of tricky because you had the 7 and then another 7. So the diameter of the circle is the same as that 14, just from the diagram there. So hopefully that helps. That was one of the first questions we had. Lesson 6 worksheet number 3, Learning Guide 1C. Lesson 5 worksheet number 3. And 2B, Savannah's question. Sorry, I'm just kind of mulling over all the questions that are stacking up in chat here. The next one I see is the Learning Guide, Volume of Right Prisms Cones, question C, 1C. So let's go to the Learning Guide. SI, surface area of right pyramids and cones. Volume of right pyramids and cones. One C, A, B, C. Is that the one we're talking about, Alex? Calculate the volume of this block of cheese. Doesn't really look like a block of cheese to me, but I'll take what we can get. Did I skip the paint answer to the last one? If the coat costs $12 per square meter, so we just multiply this by 12. And that should give us our answer. Hopefully, if you've made it to the surface area, the $12 per square meter will be an easy part. So if you can manage that on your own, that would be excellent. Alex, this is the one. I don't mean to rush through these, but I just want to get through as many as I can. Calculate the volume of this block of cheese. So what we have is a right prism. And the volume of a right prism is going to be the area of the base. So I'll just go A base. To that, we're going to add its height. Now, I mentioned this before. Now, it's kind of intuitive. You just think, well, this right prism is sitting on this surface. That's the bottom there. So that's the base. Well, that's not how right prisms work, unfortunately. The base is always the shape. So what shape is this? Well, it's this triangle here that we're dealing with. And in order for us to find the volume of it, we're going to have to find the area of this red side we'll call the base. And then we have the distance along here. This is the height. So if you think about if we had like a cylinder, if I put the cylinder, just drew it that way quickly, I'd have the area of the base here, and then I'd have the height. Why do I call that the base? What if I drew my cylinder instead of vertically? If I drew it this way, how would I find the base of my cylinder? It's just a line touching the ground. So what does the base mean there? Well, it doesn't really mean anything. So when you think about these types of shapes, regardless of what they are, anytime you're finding the volume, you're going to have the base, and then you're going to have the height there. So it's always important to identify the shape you're dealing with and then understand that it doesn't necessarily have to be the bottom in order to be the base. Base is kind of a misleading word in this sort of context we're dealing with. Base does not necessarily mean the bottom. If I redrew this shape, kind of flipped over onto its side, if I tipped it over so the triangle face was the bottom, well, now the base and the bottom are the same thing. But it can get really confusing. So that's kind of the important thing. Same with the picture up above here. The base of this shape is actually this triangular face, and then this is going to be my height along that side. Even though I have just a nice rectangle on the bottom here, this face on this end is my base. If you think about taking the shapes and stretching them out, so you have that triangle on the bottom, and then you know, stretch it out, so you have a triangle on this face, and then this is the base, and then you have the height as along the length of it. So hopefully that's kind of where you're getting caught up there, Alex. I'll continue, I'll find the volume of it. The area of the base, my base in this case is a triangle, so I have base times height divided by 2, and then I have the height, I'll just call length in this case instead of height, because I don't want to get my letters, my variables confused. So just dealing with the triangle, it looks like my base is going to be 9, and then I have the height of the triangle is 12 divided by 2. I'm not adding, I am multiplying. I'm going to multiply that by the length, which in this case is 0.7. So I have 9 times 12 divided by 2, and then I'm going to multiply that by 0.7. So I get 37.8. Check my units. Oh, you guys didn't warn me. Alex did. This is 0.7 centimeters, so that is 7 millimeters. So not only is this a question involving volume, but it's also a unit conversion question. So 0.7 centimeters, I have 1 centimeter is 10 millimeters. So that gives me 7 millimeters. So let's try that again. 9 times 12 times 7, divide that by 2. So I get 378 millimeters cubed. And then I need to convert that into centimeters. Or I could have taken everything at the beginning and converted it. This is where these things get tricky. So if, let's say you'd done it this way, you take this 378, you might absolutely hate this. And if you would have converted to centimeters at this spot, then you wouldn't have had to do this extra calculation at the end. I know that I have 1 centimeter cubed. You'll notice this cubed here. How many millimeters are in a centimeter? Well, there's 10 millimeters in a centimeter. And then if I cube it, I also have to cube my 10. So this is, instead of dividing it by 10, I'm going to divide it by 10 times 10 times 10, or 1,000. So I'm going to get 0.378 centimeters cubed. So I guess that's kind of the tricky one there. Instead of dividing by just 10, we have to actually divide by 1,000. Because if you think about a little cube, that was 1 centimeter by 1 centimeter by 1 centimeter, this would be like 1 millimeter cubed. Then I'd have, 10 millimeters cubed by 10 millimeters cubed. So to make this, how many cubed millimeters fills up like a sugar cube, I'd actually have 1,000. So that's the tricky bit there. If you'd converted all of these to centimeters at the very beginning, you wouldn't run into this problem. So maybe as a way to think about these problems, if it's asking you to find an answer in centimeters, if you get everything into centimeters first, you don't have to worry about converting using these cubes and things like that. So hopefully that helps you a little bit, Alex. Kind of two tricky ones in that bit. See what other questions we had here. Morning. Volume, right prisms, cones. Lesson 6, worksheet number 3. Did that one? Savannah is asking for the learning guide, but then you retracted that, Savannah, and you wanted 2B from the learning guide. Which section was that, Savannah? I'll just look up here. Surface area of right pyramids and cones, 2B. Surface area, right pyramids, cones. There's 1, 2B. Is that the one we were looking at, Savannah? And then number 6 of the one above I just did. Okay. Yep. Okay. So this one, again, we have a base that's in meters, a height of meters, and it asks us to show all equations and work and answers an exact value. So when we see that exact value, we're going to probably have a square root in our answer, or we're probably going to have a pi in our answer. So it also asks for an answer in millimeters, which is kind of strange, but we can go with that. So we know it's a square base. I'm going to write in my numbers here. So this is 4 meters. This is 4 meters. And it says the height is 6. So that gives me the height. And answer in meters. I don't know where I got millimeters from. Just caught on that last question, I guess. The thing that we're eventually going to have to find is the slant height. I'll call it S. So I'm just going to make sure we're finding surface area, not volume here. Find the surface area for each of the following. Okay, I'm on the right track. All right, so surface area. This is a square base pyramid. And I go to my formula sheet and I see that there's a bunch of stuff here. We have 1/2 base times. So let's just go with the total surface area formula. Is 2 times the base length times the slant height plus the base squared. And because it's a square-based pyramid, we can do that. The only sort of trick here is we need to find the triangle, to find the S. So we have the base, but we don't have this. So we need to find that slant height. So I'm going to go ahead and just draw another triangle off to the side here. Just kind of think about kind of cutting it out of the inside of the pyramid that I've drawn there. So I know the height is 6, and the base, across the whole base is 4, so half the base is going to be 2. And then I'm going to want to find this side along here, the hypotenuse, or the longest side, which is just going to be the C in my Pythagorean theorem. So see if I can just do this. A squared plus B squared is C squared. I'll go with 6 squared plus 2 squared is S squared. Now this is where this kind of exact value is going to come in, because we're going to end up taking the square root here. So 6 times 6 is 36, and 2 times 2 is 4. So 4 and 36 together gives me 40. And then I need to take the square root of both sides. We'll leave it as the square root of 40. One thing that we're actually going to go through in the next couple days is how to simplify this square root of 40 a little bit further. So I have a feeling the answer's probably has a square root, but it's not the 40 in it. So we'll just learn how to deal with that in a few days' time. It's not going to happen on a test, the test you guys are going to write. And if it does, I can go in. When you guys write your tests, I go in and check the answers you got to make sure everything kind of makes sense. So I don't want you to stress about that too much. The base length is 4. This is root 40. And then I have 4 squared for the bottom. So we're going to have 8 root 40 plus 16. Square root of 42, 4, and 10, 2, 16. So that would be kind of good enough if you made it that far, Savannah. I know the answer doesn't look like that. So let's figure out what this is as a decimal, just as kind of good practice. So I'm going to take the square root of 40 and multiply it by 8. I'm going to add 16 to it. So I'm going to get 66.59 meters squared, because it's surface area. So if you got that far, Savannah, that's great. Don't get caught up in the exact value, because we'll deal with that a little bit later, and then we'll worry about exact values in unit number 1, which is what we're doing after unit number 2, kind of backwards. So yeah, don't get caught up in the exact value for now. If you ended up with either that or that, either the decimal or the radical there, that's perfectly fine. So there you go. I've kind of lost track of some of these questions because the chat has continued on. So I'm just going to scroll back up here. I believe I got Savannah's. Haley, I didn't get yours yet. Lesson 5, worksheet number 3. That was this guy. 2, 3, the golf ball one. Is that the right one? Haley, if you want to give me a, yep, that's good, or something like that. The golf balls. Excellent. All right, so this is a really kind of a tricky question, because there's lots of different kind of ways you can approach it. So it says there's a dozen golf balls. I guess the first thing we need to know is a dozen means 12. So that's kind of the first step. Surface area of hemisphere? Sure, Devin, I'll get to that maybe after I go through a couple more questions. So a dozen golf balls fit inside a box in the shape of a rectangular prism. The golf balls are packed tightly together. They touch the top, bottom side. What percentage of the area within the box is air? So you're thinking, Mr. Borden, you've lost your mind. There's no numbers in this question. How can we possibly figure it out? That's a good question. First of all, let's think about our box here. So the box is kind of included here, and it doesn't really even matter how you draw your box. We're going to pretend those little circles I've drawn are all touching. Maybe I should make them touch so I don't confuse anybody. I need to draw 12 of them though. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You wouldn't believe how hard it is to do that with this pen. Anyways, I have 12. It doesn't matter how you've drawn your box. You could have drawn your box like you could have had 12 golf balls and it could have been 1 high. sort of thing. So you could have drawn it that way, or you could have drawn it the way I drew it, or any combination of 12 that you can get. So I've chosen to go 4 by 3, which is going to give us the 12. So I have this guy here is my radius. So if I were to count how many radiuses or radii to get all the way across the edge of that box, and do the same thing going up and down. I have a radius here and a radius here. How many would I have on this side? All right, so if I went across my blue ones, I'd have 1, 2, 3, 4, 5, 6, 7, 8. So I'd have 8 times the radius. Or if you want to just say the radius is equal to 1, I can do that. It hasn't given me any values, and it's asking for a percentage. So I can just say that the radius of my golf ball is 1. It doesn't matter. You can just make it up, which seems kind of weird. If I were to go down with my red lines here, I'd have 1 radius, 2, 3, 4, and then 5 and 6. I'd have 6 times my radius. And then if you think about it, if I attempted to make this three-dimensional, drawing the same golf ball in there, I'd have just the edges of these golf balls here. Kind of happy with that. Doesn't look terrible. I guess it actually does look terrible, but if I had a radius of my height here, I'd have 2 radii. So in order to find the volume, I have 2 things I need to do first. So first is the volume of my golf balls or my spheres, which is going to be 4/3 pi. Maybe I'll leave a little room here. 4/3 pi r cubed. And how many spheres do I have? I have 12 of them because it's a dozen golf balls. The second thing I need to do is I need to find the volume of the box. Now, just for the sake of this question, I'm just going to say the radius of these balls is 1, just because it just makes life easier. I could do the entire calculation with a radius in there, so I'd get 12 times 4/3 pi, and then my radius would be just r. Or I could just put in 1. And dealing with 1 makes me happy because I know my 1 times tables very well. And then I have the volume of my box, which is going to be 8 times 6 times 2, or 8 r's times 6 r's times 2 r's. But if my r is just 1, then that's fine. So let's figure out the spheres here first. 4/3 times pi times 1 cubed. I'm going to go 12 times 4 times pi, and then I'm going to divide it by 3. So I'm going to end up with 50.26 for the volume of my spheres. I don't have units, so I don't have to worry about that. The second thing is calculating the volume of the box here. So 8 times 6, give me 48 times 2, should be 96. So it asks what percentage of the area within the box is air. This is kind of where this question gets tricky. Assuming you got this far, it's asking what percentage is air. So this is the volume of the box, the whole thing. If I filled it all up with sand, it would be 96 grains of sand to fill it up. The spheres only take up this 50.26. So to figure out the volume of the air, I'm going to take the 96 and I'm going to subtract the 50.26. So the 96 minus 50.26 gives me 45.74. That is some volume is air. So if this 45.74 is air and the total is 96, if I want to figure out the percentage of air, I need to take the volume of the air divided by the total volume. Or in this case, the volume total is actually the volume of my box. So 45.74 divided by 96. Now, $45.74 divided by 96. 47.6. 48%. Is what I ended up with. Taylor, you're always correcting me. You're way smarter than I am. What's going on? So that's kind of the idea there. You need to find the volume of the spheres. You need to find the volume of the box. Then figure out how much of it's air. And then once you've done that, you can figure out percentage of air. The important thing is that you kind of understand how to get the length and the width. Because that is kind of the tricky bit there. The rest of it, I could understand if you didn't get it that far. And they can ask questions a lot of different ways in regards to this sort of question. See if I can find the next one. Lesson 5 worksheet, half a cylinder. Savannah, Haley, I just did yours. Surface area, question from learning guide number 2. 2B for the question. Okay. Taylor, learning guide number 6. Above the one you just did, but that was 2 questions ago. Is this the one you're talking about, Taylor? You said above. I'm confused as to which one you're asking about, Taylor, so if you can throw it in again. The sheet, the section, and the number. Surface area of right pyramids and codes 1C from the learning guide. I think I did that one, did I not? Surface area of right pyramids and codes 1A, B, C. And Taylor said yes, but Taylor, I've moved on. So you're going to have to put it in again. 6, above the volume of right pyramids and cones, pyramids, page 8. 6 above. This one here, a cone-shaped pile of topsoil. Is that the one, Taylor? The one about the topsoil needs to be covered with plastic, diameter of the base. That's on page 9, but that's the one you're talking about. Okay, cool. Maybe I'll do these 2, and then hopefully I'll have a little bit of time to mosey on into the next section. So we're trying to find the surface area, and we've got some numbers here. I did volume. Does that mean you want me to do the surface area, Alex, or was it the volume that you wanted me to do? I just want to make sure that I'm not kind of wasting time on questions we're not interested in. I haven't done a surface area